Open channel flow. Flow in open channel is defined as liquid with a free surface. A free surface is a surface having a constant pressure and atmospheric pressure. Thus, a liquid flowing at atmospheric pressure through a passage is known as flow in open channel. In most of cases, the liquid is taken as water. Hence, flow water through a passage under atmospheric pressure is called flow in open channels. The flow of water through pipes at atmospheric pressure or when the level of water in the pipe is below the top of the pipe is also classified as open channel flow. In case of open channel flow, as the pressure is atmospheric, the flow takes place under the force of gravity, means the flow takes place due to the slope of the depth of the channel only. The hydraulic braiding line points to the free surface of water. Types of channels. Open channel flow is a flow that has a free surface and flows with the gravity. Pipe not flowing full also fall into the category of open channel flow. In open channels, the flow is driven by the slope of the channel rather than the pressure. Open channel generally is classified into two categories. One is natural channel, that means the irregular shaped channels. Another one is artificial channel. Artificial channel is a regular shape of channels. Types of flow: steady and unsteady flow, uniform and non-uniform flow, laminar and turbulent flow, subcritical, critical, and supercritical flow. Steady and unsteady flow. Steady flow, the flow characteristics such as depth of flow, velocity of flow, rate of flow at any point in open channel do not change with respect to time. The flow is said to be steady flow. The flow is unsteady if the depth is changes with respect to time. Then it is called as the unsteady flow. Uniform and non-uniform flow. If for a given length of channel, the velocity of depth of flow, slope of the channel, and cross-section remain constant, the flow is said to be uniform. The flow is non-uniform if velocity, depth, slope, and cross-section is not constant, then it is called as non-uniform flow. Types of non-uniform flow. Non-uniform flow is classified into two categories. One is GVF, another one is RDF. GVF, gradually varied flow, and rapidly varied flow. Gradually varied flow if the depth of flow channel changes gradually over a long length of the channel. The flow is said to be gradually varied flow and is denoted by GVF. And rapidly varied flow. Rapidly varied flow is defined as that flow in which depth of flow changes abruptly over a small length of the channel. When there is any obstruction in the path of flow of water, the level of water rises above the obstruction and then falls and again rises over a small length of channel. As the depth of flow changes rapidly over a short length of the channel, for this short length of the channel, the flow is called rapidly varied flow. This is the uniform flow. Uniform flow is flowing here and there is an obstruction. Then the uniform flow changes into non-uniform flow. This is the flow direction. This is another example. UF, uniform flow. GVF, gradually varying flow. RVF, rapidly varying flow. Here is the tank and flow is going here, the pathway. Then this we consider as the rapidly varied flow. and here uniform flow, and again rapidly varying flow, uniform flow, and here is the gradually varying flow, laminar and turbulent flow. Both laminar and turbulent flow can occur in open channels depending on the Reynolds number. Reynolds number or E equal to whole P R divided by mu. Mu is density of water. Generally, density of water is a standard value 1000 kilograms of meter cube. Mu dynamic viscosity and hydraulic main depth. That is, R is equal to area by meter perimeter. This is the turbulent flow and this is the laminar flow. Reynolds number is less than 500, then that flow is called as laminar flow. Reynolds number greater than 500 and less than 1000, then it is called as a transitional flow. Reynolds number is greater than 1000, then it is called as a turbulent flow. Subcritical, critical, and supercritical. The flow in open channel is said to be subcritical if the Froude number is less than 1. Then the Froude number in T is defined as V divided by root of G into T. Where V is velocity of flow and D is hydraulic depth of channel and is equal to the ratio of vector area to the top width of channel. Then it is as hydraulic depth as A divided by T, where T is top width of the channel. Subcritical flow is also called trickle and streaming flow. For subcritical flow, Froude number Ft is less than 1. The flow is called critical flow. Froude number is equal to 1. And Froude number is greater than 1. The flow is called as supercritical or shooting or rapid flow or torrential flow. Here is the subcritical to supercritical flow. Here the slope is very steep slope. Then the flow is converted to subcritical to supercritical flow. And here supercritical flow is converted into subcritical flow. Supercritical flow, here it's the flow is flowing like a supercritical flow. Then the translational, then the state and slope will be changed. Then the flow is converted with supercritical to subcritical flow. Types of flowing water and its control. Critical section in uniform and non-uniform flow. Here, SO is less than SC, then Y is greater than YC, and it is called as a subcritical flow. If SO is equal to SC and Y equal to YC is called as a critical flow. Velocity distribution. Velocity is always vary across channel because of friction along the boundary. The maximum velocity usually found just below the surface. Here it's the lines of constant velocity. Then the cross section of the velocity is changes uniformly. Here is low velocity. Then it is increasing, and its continuously going to decrease. This is the actual velocity, and then it is the uniform. Here we see the cross-sectional trapezoidal channel, and then here the flow is going like this. Here is the shear distribution diagram. Geometric properties of open channel. For open channel, rectangular and trapezoidal channels are there. Rectangular channel with top width called as B, and then area B into Y. Vector perimeter B plus 2Y. Y is depth of channel. Trapezoidal of width B plus 2my and area by plus my square. Method perimeter b plus 2y root of 1 plus m square. The r is hydraulic radius. It's defined as area divided by method perimeter. And the d is denoted as hydraulic depth. And it is find out area divided by d. Discharge through open channels. Discharge through open channels, we find out the constants. This is constant, Manning's constant, Basing's constant, and Hooker's constant. Discharge through open channel, Chassis by using Chassis formula. Here, you see this diagram. This is the datum line, and the load acting here is W. This is uniform flow in the channel. Forces acting on the water between section 1 and 1. Section 1 and section 2. Forces acting the section 1 and 2. Component of weight of water is W sin theta. Section resistance is equal to F L V square. Then W is equal to density into volume. Density W A L. Equate both forces. That is the forces acting here. Here the forces acting there. F P L is equal to W A L sin I. This is formula is B equal to C into root of M into I. B is equal to root of W divided by F and root of A by P sin I. This is equation 1. A by P is also denoted as M, that is hydraulic radius, and root of W by F is equal to Chassis constant. Then we write formula in B equal to C into root of M into sin I. For small value of sin I equal to tan I equal to I. Then we cancel this sign. Now the formula is velocity is equal to this is constant C into root of M into I. This is formula. And Manning's formula. This formula can also be used with Manning's roughness of coefficient, where C is equal to 1 divided by N or power 1 by 6, where R hydraulic radius and N Manning's roughness coefficient. Basing's formula. Chassis formula can also be used with Basing's formula. Basing's formula is C is equal to 157.6 divided by 1.81 plus K divided by M. The K is Basing's constant, M is hydraulic radius. And most economical section. Most economical section is the cost of construction should be minimum and at the same time the discharge should be maximum. Types of channels based on shape: rectangular channel, trapezoidal channel, circular channel. Basic discharge formula is Q is equal to A into B. Then we know B is equal to C into root of M into I. Then we write Q is equal to AC root of M into I for discharge formula with the Chassis constant. K is equal to K into 1 divided by root of P, where K equal to AC root of A into I. If P is minimum, then Q will be the maximum. This is the rectangular section for most economical section. This is B and this is the D. Now, area of the rectangular section is equal to breadth into depth. Now, B is equal to A divided by D. The perimeter of the rectangular section B is equal to B plus 2D. Here, substitute the value for B, A by D plus 2D is the equation 2. For most economical section, P should be minimum. Then we apply the differentiation P divided by D gives C into A divided by B plus 2D divided by D into D. Then it's converted into D is equal to 2D squared. Then D cancel, we write the formula for to B by 2. This is the condition for rectangular economical section. And then M is equal to A by B. Here A is equal to B plus B into 2. B is equal to B plus 2D. 2D square is converted into D by 2. For most economical section, for rectangular section, conditions 2, one is B is equal to 2D and another one is D by 2. Next, circular section. Trapezoidal section, the most economical conditions is B plus 2ND divided by 2 is equal to D into root of N square plus 1 and M is equal to D by